This video on how to deal with files in Python. It's a supplementary piece for Chapter 10 of the book, An Introduction to STEM Programming with Python 3. I'm James Reneau Ph.D. from Shawnee State University, and I'll be taking you through this video lecture. In this video, we're going to cover what is a file, how to read and write files through Python using the open command. We'll be using Python's context manager, which is a kind of a new idea for us in this course, to make sure that we clean up our file and make sure they're opened and closed correctly. And it's really the right way to do things. There are some other ways, but I'm going to show you the way I want you to use the context manager. We're going to talk about how to open a file using the open function for reading, writing, and appending to a file. We're going to write lines of text to a file, write lines of data. We're going to read a file using a loop, and then we're going to read a file one line at a time using the read line. So that's what we're going to cover in this video. The first thing I want to talk about is the open function, and it's open close parentheses, and you give it a couple of arguments. And what the open function does is it opens a file. Now, we all know what files are. We see them in the folders on our computer. We see them in on our personal computers and on our tablets and things. It's a place on the computer's long-term storage, hard disk or memory stick, where data can be stored and kept for a long period of time. Computer shuts down, you don't lose your files. It'd be horrible if you did. So an open statement is used to read into that. It creates something we call a stream. A stream is a sequential collection of data that we can get stuff from. So when you open up a file, you basically think of it as a garden hose. And it's a hose of data. As long as you want to drink, there's water coming off of the hose. You just drink more water off of the hose, and the hose keeps delivering water until all the water's gone out of the stream. Or vice versa, it's like a pipe. You put water in the pipe and it goes into the file. So open opens up what we call a stream. The open function takes two arguments. The first argument is the path to the file. It's a string that contains the name of the file or the folder and name combination to the file. And the second is a string that contains a few letters. The letters that I want you to know how to use are R, W, and A. R for read, W for write, and A for append. Append basically says go to the end of the file and open it up for writing, but leave the content of the file still there. Lets us add stuff to the file later. Comes in handy. There are two other letters that you probably should at least be aware of, and that's the letter B and the letter T. So the letter B says open the file for binary reading and writing, which means open a file that can contain non letters and numbers and can contain special characters. But all of the files we'll be using are files here in this class, at least, are text files. So if you were to say RT to open with the mode of quote RT, it would read a text file, or WT would write a text file. And because T is the most common, you can just leave it off. So we're going to open up a file using the mode R to read, W to write, or A to append. And basically what happens is open gives us a variable, gives us what's an object that contains a file pointer. And when we're done with that file, we must close it. And that's where the context manager comes in, because it's going to close the file for us automatically. We've got to tell the operating system, okay, we're done. You can take this out of your memory now and push it to the hard disk, push it to the permanent storage or semi-permanent storage. So for every open, there must be a close. But instead of showing you the close function, I'm going to show you the context manager, which is the way I want you. A context manager basically automatically closes the resources of an open file or an open database or some other kind of open stream when we're done with it. When we're done with the code, just close it up, wrap it up, make sure everything is nice and clean and flushed out to the hard disk or to wherever it needs to go. The command to start a context manager is with. Statement to start a context manager is with. And we say with the function to open the context manager as a variable name, and then have a suite of code. And that suite of code, that variable contains an open link to whatever we to that context. Once we step out of that suite with the context manager, will close up that resource so that everything is done. The file has been closed and can be opened by another process. So we're going to use the with statement to context manage. So let's look at our first Python program here that works with files. This program is going to write the number 0 to 99 to a file, with each number being on its own line. Let's look at the code. On line 1, you can see I begin a context manager that says with open numbers.txt, comma, quote W quote. So it's going to open a file in the current folder where your program is saved called numbers.txt for writing. And it says as f. So f is going to be a variable that contains the file pointer, a pointer to the file or the file object that we will use within the context, within the indented code, within the indented suite of the with statement. You can see on line 2, we use a for statement to generate the numbers 0 through 99 in the variable n. And then on line 3, we say f.write, whatever our variable name is. And you could have used a different variable name other than f. I just used f because it's a nice short word for short abbreviation for file. But I say f.write, and then I write a string to the file. Got to write a string to the file. You just can't write numbers or other things. You've got to write strings. So you can see that I convert the n, the number n, to a string with stir n. And then notice I add this crazy string at the end. I add a plus quote \n quote. I've not talked about escaping special characters, but \n represents the non-printable character of a carriage return. At the end of each line in a file, there's a character. It's an ASCII 10 or an ASCII 13 or a combination of those that tells the operating system go to the next line. And that \n says write out the number and go to the next line. If I would have left that \n off, it would have put 0, 1, 2, 3, 4, 5 and just jammed them all together all on one long continuous line. But that \n, known as the end of line character or EOL, tells the operating system move on down to the next line, and we're continuing to put data into this stream. So you can see the result of that file, and I opened it up and I got rid of some lines in the middle because it wouldn't all fit, was to create a line with a file with 100 lines, the numbers 0 through 99, and then on line 4, I indent out of the suite. So at line 4, the variable f no longer exists because it was part of the suite. It's not now. The context manager has closed the file. The resources have been returned back to the operating system, and it prints the word done that you can see here. So that's writing data to a file. So now that we've written data to a file, and again, you can write any string you want to a file or any group of strings to a file. Remember, carriage return between or the \n between each line. Let's start reading data from the stream. So we've put data out. We now have a file called numbers.txt. Let's read it in. So we use the for statement, and the for statement will like we've seen for used in loops of looping through items in a list and looping through items in a dictionary or tuple. The for statement will read each line one line at a time from the file until there's no more data in the file, and then the for will just end. So the for statement will read 0 lines if the file is empty, up to however many lines there are in the file, 0 or more times. It returns an entire line as a string. Now, it also returns that crazy \n or that end of line character at the end of the line, and we probably want to strip that off before we do anything with that string, because the string contains what we wrote out, but it's got that stuff at the end that we put out there because we had to, but we want to get rid of it. You can use the rtrim method of a string that we talked about back in the string chapter to remove that white space or that carriage return or that end of line character, as it's called, from the end of that string. So let's use the for statement to read in a file. I'm using the numbers file that we created before, but this file could contain any list of integers or any list of numbers, one on a line, actually integers. Let's look at the code in detail. On line 1, we open up, and what the program is going to do is it's going to sum all of the numbers in a file. So we have a file full of numbers. We don't know what the file looks like. The file doesn't have to be this numbers. It could be a different file called numbers.txt. But it's going to read in a file of whatever it has and sum up all of the integers in that file. So on line 1, we open the numbers.txt file for reading this time instead of for writing using the quote R. On line 2, I set the variable total equal to 0 because we've got to have a variable to accumulate that total into. On line 3, I say for line in F. So F is kind of like a list, but it's the file. And what happens is each time we loop through the for statement, line will get the next line from the variable line will contain the next line from the file. You could have called it something else besides line. Just kind of makes sense to call it line to me because I'm getting a whole line. And so on line 4, you can see that I convert the line to an integer. So I take that number that we read in, that string that we read in, convert it to an integer, I then add it to total and save it as total. So total grows each time we go through the loop. If the file contained 10 numbers, it would total up 10. If the file contained 1,000 numbers, it would total up 1,000. It doesn't matter. And on line 5, we step out of the suite, close the file because we no longer need it, and step out of the context manager and print out the total. And you can see that the total of the numbers 0 to 99 is 4,950 because we read it from the file. The file object will also has a method called readline, and what the readline method does is it reads one line. The readline returns the next line in the file. Because maybe you don't want to read all of the file. Maybe you just want to read a couple of lines from the beginning of the file. Maybe you want to read until you get to a certain point and then quit. So the readline method of the file object returns the next line as a string. The EOL character is still hanging out there on the end, and it returns a false when we get to the end of the file. So when we get to the very end of the file, it returns a false value instead of a string. So we can use that in a loop to read the whole file in. Here's a different way to do the same program that we did with the for, only this time I'm using the readline. Notice that lines 1 and 2 are the same. We open the file for reading, but on line 3, I set line equal to f.readline. So the variable line on line 3 contains the first line of data. So it would contain a 0 with a carriage return as a string. Then I say while line because line would be a true value because it's a string that contains something, right? So total equals total plus end of line. And then on line 6, I read the next line. So on line 6, I would read 1, jump back up to the while. Yes, it's true. Keep going. Read the next line. But when I get to the end, when line is 99, I then read the next line and it says, no line here to read. We're done. So line would be equal to false. Jumps back up to the while false. It says, nope, I'm out of here. pops back out to line 7, closes the file as we leave the context manager, and prints the same total of 4,950 for the numbers.txt that we wrote out in the first sample program. In the creation of this video, I did go look up the definition of what a stream was in computing, and the definition at Wikipedia wasn't a bad one, and the definition I gave earlier was kind of taken from the ideas there. Remember, this presentation is copyright 2020 by James Reneau Ph.D. You can contact me at jreneau@shawnee.edu. This work is licensed under a Creative Commons Attribution, Non-Commercial Share-alike 4.0 international license, and I would like to say thank you for watching.